Okay, it's about 10:15 right now, and I've just completed integrating the sonar and the temperature sensor so that it could be displayed on the single LCD. And the way I've done this is to use two separate modes. So one is the temperature mode and one's the sonar mode. And while the chip is working on the temperature mode, the sonar is useless, and while it's on sonar mode, the temperature sensor is useless, and essentially the analog to digital converter is turned off. As you can see right now, it's showing 21 degrees Celsius, which means that it's in temperature mode. And I have essentially just put a button here to cycle through the various different modes. Here, currently on this chip, I've implemented only two modes, which is of course sonar and temperature. But this opens the door up for as many kind of cycles as you would like. And really, because this chip, although it has many input-output ports, it's still limited in number, and it's quite useful to sometimes cycle through the separate modes. And one very useful um, uh, application of this is to make especially on chips which have a small number of input-output ports, to make a calculator, for instance, and to implement the various different functions such as addition, subtraction, multiplication in this cyclic fashion. So you cycle through the different modes or the different operations, and once you've selected one, then you move on. And I'll just demonstrate this right now. So if I press this button, it takes it to sonar mode, and here we go. So as you know, here is sonar mode, and if I put my hand over, sorry, I just have to remove this. Okay, so right now it's showing okay 20 centimeters. So this is the phone, which is 20 centimeters away, 19. And if we move in closer and closer, you can see that the distance between the sonar, the sensor, and the phone gets smaller, and it's displayed on the LCD. Right, okay. Actually, sorry, there's a small error over here. That 0 should not be there. It's just a matter of clearing the 0. Actually, it's just, what it's showing is 9 centimeters, not 90. So that 0 should not be there. Okay. And you can move back into temperature mode. Go. And again, it's showing 21. And if hopefully my hands are warm enough to heat this, you can see that it goes up 24, 25, yep. And again, you just cycle through this, the various different modes. Right now it's just two modes, temperature mode. Now you'll notice that it takes a second or so for the number to be displayed, so you can see. And that's essentially because what I'm doing here is for this button, I'm using one of the external interrupts, and once it does all the calculations and it sets the program up to change modes, it returns back to the mode it was in at the time the interrupt was given. So it completes that cycle, and so there are various delays and other things which are inside the program in the mode that it was in at the time, and it has to complete the entire full mode to go to the next stage, and that is really the timing difference that you see. So if I click this, you see it takes a little while for the number to show up, and that's just because it's completing all the completing the calculations, or completing the delay cycles and everything for the previous mode, which is okay. And so for that reason, actually, I thought that it'll be a good idea to actually show the units, centimeters or centigrades, before the number is showed, so that the user feels like as if yes, the mode has changed and that the number is coming up soon. Otherwise, it would just show nothing, and for a moment, it would just give a feeling of kind of something's gone wrong, which really hasn't. It's just the as I said, delay cycles and things have to be completed before it can carry on. Now, yes, again, it's using the same chip here, the PIC 18F4220, and operating at 8 megahertz, which means 2 million instruction cycles per second, and that's it. Now, one of the greatest challenges that was in this for this coding was not really the programming itself, but just to kind of actually the program becomes quite long at this stage because it has to account for the LCD. It has to interface with the LCD. It has to interface with the temperature sensor and the sonar. So it's just a long program, and it was just a matter of structuring it correctly. So you can see that I have all these comments everywhere, just indicating what's what. Okay, so these are all the functions. Starts off with the LCD functions. So up here, this is the main program and other definitions. And actually, the challenge really was, in programming terms, was to get rid of this delay that I was talking about. Now, I haven't been able to do this yet. I think to get rid of this, kind of delay between changing modes and the number showing up, what I have in mind is for actually the delay cycles, to modify the delay so that while the system is being delayed, it also checks that an interrupt has occurred and it's changed the mode, so that it skips over the delay and carries on to the next mode. But I haven't exactly thought this out through fully yet. So I'll be trying to get rid of this delay, but it's not such a big issue because the delay isn't very long, and I guess it gives a feeling of uh, heavy processing, you can say, because it takes the number to come up. It takes a while for the number to come up, and yeah. But it'll be nice to get rid of the delay. So as soon as the button is pressed, the number comes up. Slight delay there. That's pretty much it, really. Again, I'm just using the Picket 2 to power the device at this point, also to program it earlier, and that's pretty much it.